and only start building stuff after an hour or two. We'll learn all of that here on a concrete Flutter app, arguably not the most beautiful one. We'll build way more beautiful applications later throughout the course, but that simply is the case because here I want to focus on a lot of functionality and features and behind the scenes stuff, and not so much on the layouting and styling stuff, which we'll also have a look throughout this course though, no worries. So we will build way more beautiful applications throughout the course. We'll write a lot of code across multiple files. We'll build our own widgets, and you will learn a lot about passing data around, managing data, styling to a certain extent, and core Dart and Flutter features. So let's dive in. So let's dive into Flutter then. And for this, let's create a brand new project. For that, open up your terminal or command prompt on your machine, so the default Mac OS terminal or your Windows command prompt. And in there, make sure that with the help of the cd command, which allows you to change directories, you navigate into the path where you want to create that new project. So here I navigated into a playground folder, for example. It doesn't matter how you name that folder, but it should be the path where all your project files are stored thereafter, or where this new project folder is created in, to be precise. Once you're in that path, we can use the Flutter command, which is available since we installed the Flutter SDK in the first course module. And we can run the create command there to create a new Flutter project in that place where we navigated to. So now with that, you can give this project any name you want, like Flutter course, or I'll name it Flutter complete guide. The name is up to you, and this just wrapped over 2 lines, so it's one name here. Make sure that in that name, however, you only have one word, so Flutter complete guide, it's one word, where the individual words are separated with underscores. Don't use dashes or blanks there, that will not be allowed and you'll get an error. Instead, use underscores for that project name. And this will then go ahead, once you hit enter, and scaffold out this new Flutter project for you. So now this creates this new folder, that Flutter Complete Guide folder, in the path where you navigated to. And inside of that folder, it gives you all the base setup for a new Flutter project. And by the end, you should see an output that looks something like this. You can ignore warnings you might be getting here. If Flutter Doctor basically showed you the same, it should work here. And now you can run these 2 commands to navigate into that newly created Flutter project folder and to then also run your Flutter project. However, I'll not do that here. Instead, I opened up the project here in Visual Studio Code, which is the IDE I'll be using throughout the course. Now, as you learned in the first course section, you can use either Visual Studio Code with the Flutter extension installed, as we did it in the first course section, or you use Android Studio, which is also absolutely fine. However, I prefer Visual Studio Code, and therefore that's the IDE I will use throughout this course. Now, this is Visual Studio Code just configured as I showed it in the first course section, nothing else. And this is this Flutter project, which we just created here in the command line. So this is the project and all the default files and folders we get in there. Now, in the next lecture, I will walk you through all these folders and files and explain what they do and with which files we will work mostly. But first of all, let's make sure that we can also see our app, not just in code, but on a device. And for that, you could use a real device connected to your machine. And of course, I also will show you how that works in detail later. But for now, let's simply use an emulator, a virtual device. And I will pick a virtual Android device, since that works on both Windows and Mac OS and Linux, whereas iOS devices, iOS simulators, iPhone simulators only work on Mac OS. Nonetheless, later down the course, I will also show you how to run this app on an iOS simulator, so you will also learn that. Now, to launch the app onto an Android emulator, we first of all need to create an emulator. And for that, you should start Android Studio, which you had to install anyways. And you should see that welcome screen there. Now in there, if you click on Configure, you should have the option to choose the AVD Manager. If you don't have that option here, you can open an existing Android Studio project and there simply navigate to the Flutter project you just created. So that's the Flutter project I created with Flutter Create. And in there, choose your Android folder as an Android project, because that is a real Android project that's part of your Flutter project, your Flutter app. Now, once this opens, you could write code here, Android code, which we certainly don't want to do. We want to write Flutter and Dart code and get an Android app automatically. I only opened this because here, under Tools, once this initialization here finished, which will take a couple of seconds, you'll also find that AVD Manager. So in case you didn't see that on the welcome screen, well then you can go here to Tools and find the AVD Manager here. So you should find it in either of the two places. If you find it in neither of these places, you should try to reinstall the Android SDK and possibly the entire Android Studio. But once you found it and you open it, you should see a screen that looks something like this. Here I already got a couple of virtual devices. You might not have them yet. And you can simply create a new one with the button here in the lower left corner if you click on Create Virtual Device. Now in here, you can create different virtual devices, and we'll use a phone in this course for testing. And you have different blueprints here. For example, you can create a Pixel 2 or Pixel 3 device. You got other blueprints here. Also depends on the point of time you're watching this. You got really old or small devices as well, which we'll also use for testing later to see if our app works well on these devices as well. But for the moment, I'll go with the Pixel 2, and I would recommend that you also pick an image where you have this image here next to Play Store, this play button style here. Because if you have that icon here, that means that this image actually comes with certain extra services installed, which make development with things like Google Maps and so on easier, or which makes testing these features easier. And that will help us later down the course. However, you could also launch a new simulator with that feature once we need it and go with a different one for now. Nonetheless, I will go with the Pixel 2 here and click Next thereafter. Now you can install, and you should install, a system image, which is basically the Android version that runs on the device. Now I would recommend that you use the latest stable version here. Now I could use Android Q here, and when you're viewing this, this might already be the latest version. But right now, when I'm recording this video here, this is the latest Android version that is available, the latest stable Android version. And I don't want to develop for an unstable or under development version where certain features might not work, and therefore I'll use this. Now, if you don't have that already, you might need to simply download this image first by clicking that download button. So choose that latest stable version here and click Next again. And now you can give this emulator a name if you want to. I'll stick to the default. And all the default settings here should be fine. You could configure some advanced things, but only do that if you really know what you're doing. I will instead go with all the defaults and then click Finish. And now this creates this new virtual device, adds it to the list here, and now you can always launch it here by clicking that play button. So that's exactly what I'll do here. I'll click that play button here, and this will bring up the new virtual device, which is now booting up here. This is the virtual device on which we will now run our app as soon as it is done booting up. Here we go. This just finished booting. And now if we go back here into our project, we can run this Flutter app on this device. Now for running this, we got a couple of options. You can open up the terminal in here by going to your menu here and clicking on New Terminal. And this is now your normal system terminal or command prompt just running inside of Visual Studio Code. And it automatically navigated into this project folder, so you don't have to do this manually with the cd command. Now here you can run Flutter run, and it will run your app, and it should automatically find this application here. You could absolutely do that, but with the help of this IDE and the Flutter extension which we installed in the first course section, we got an even more convenient way of running our app. You can go to Debug here, and now you have two options of starting your app. You can start it in debugging mode, or either by clicking here or by using this shortcut here. And this is something I'll show you later in a separate module where I will show you how you can debug your Flutter application and find and fix errors. You can also run it without debugging, which is a bit faster, because with debugging, a lot of extra features get added to your app, so to say, for debugging only. And if you run it in non-debug mode, you simply have a bit of a faster app, which is a bit nicer for normal development. That can be run by clicking here or using this shortcut. And if you click this, it should also automatically spot your device. However, first of all, you have to choose, at least if you have multiple different extensions installed, with which environment you want to run your code, and that would be Dart and Flutter here. So choose that if you are prompted. And now it will auto-detect the emulator and launch this application that we have in this folder here on that device. So as you can see here in the bottom right, it's now building the project with the help of Android Studio and the Android SDK. And here, the top right, you have that control bar, which allows you to control the execution of this app. You can always stop it by clicking that red stop button. You can reload the app, restart the app on the device with that green refresh icon. You can hot reload with that flash, and hot reload means that changes that you made are added to the already running application, which is a really cool feature Flutter supports for development. Makes development much faster because you don't have to restart your app all the time. You can also pause if you want, and you can then, these buttons are helpful for debugging later. So that's the control panel we got here. And the build process here takes a couple of seconds up to minutes. The first time you run this, subsequent reloads, when you change something in code and you want to see that in the device or on the device, that will be much faster. So it's just that first load, which takes a while. So let's wait for this first launch to finish here. In the meantime, let me also mention that it probably automatically switched here to the debug console. So not the terminal anymore, but the debug console. And that is the console where you will see all the output whilst the app is running. So any errors will be shown here, but also some system messages which you might want to print will also be shown here. And we'll work with this quite a bit to fix errors we might be getting, or to see a certain output to validate that everything is working correctly in our application. So here it's now starting up. These are all default log messages which we're seeing here. And you should then see your app run on that emulator as I do it here. And you then can press this button here in the bottom right corner to, well, interact with your application. Now, the first time it's loaded, the first few clicks might be a bit slow here, but thereafter you should be back to normal interaction speed. So this is the Flutter app which we just created running on that emulator. And this is the code or the project in which we'll work on the code. Speaking of that, let's now walk through all the folders and files we have here and understand what they're doing. So we got quite a lot of folders and files here. Now, a lot of the files you see here are only there for configuration, and a lot of the folders here also don't need to be touched by you. But let me explain what each folder and file does. Let's go from top to bottom. The idea folder here holds some configuration for Android Studio. It doesn't really matter for us here because we're not working with Android Studio, and you don't need to change anything in here. VS Code is a folder you might not have. I have it here because I added some extra configuration for this project. I set the zoom level so that you can see my code. And anything you do configure for your VS Code, your Visual Studio Code project here would end up in such a config file. And you don't need that if you don't have any special development options here. The Android folder is super important. It holds a complete Android project, as you could also create it without Flutter. This is in the end the project which the Flutter SDK will use to kind of merge with your Flutter code, you could say. So when your Flutter code gets compiled to native code, it will basically get injected into this Android project, you could say. And that is the Android project which later will be built into a real Android app, or later actually is the wrong word, which already got built into this Android app we're seeing here. So this is in the end a normal Android project with your compiled Flutter code. And you don't need to change anything in here, or very rarely, and I will mention when you do need to change anything here. For the most part, for the most time, this is a passive folder which will be used by Flutter, and therefore it's super important, but not a folder you work on. The build folder is also very important. In the end, this holds the output of your Flutter application. In this case here, also some Android or Java files. And this folder is generated and managed by the Flutter SDK. You shouldn't change anything in there. That will all be done automatically by the Flutter SDK when you are developing or when you are building your app for deployment, which we will do at the end of the course. And therefore, this is also a passive folder. So thus far, no folder in which we would work. It's the same for the iOS folder. We had the Android folder with a full Android project, which is important for building an Android project, both for development and for production. And the iOS folder is simply the same for, well, iOS projects. Now, on Windows, you won't have that folder because on Windows, unfortunately, you can't build iOS applications. That's not allowed by Apple. On Mac OS, you will have it, and this holds a normal Xcode project. Xcode is the development environment of Mac OS for iOS apps, and just as with the Android folder, this is a folder where you really won't work in too much. There are some occasions where we will do some work in here, but I will mention when this is the case. For the most part, this is a passive folder which gets kind of merged with your Flutter code in the end, and which will all be managed by the Flutter SDK to get iOS applications, both for development and testing, as well as for the real application in the end, which you deploy. The lib folder is now the important folder for us. Lib stands for library, and that is the folder where we will do 99% of our work. It is the folder where we will add all our Dart files. Dart is the programming language Flutter uses to write the code for our Flutter application. So this is the folder where we will add files and where we will write code in. This is a super important folder for us. The test folder is a folder which won't be too important for us here. It allows us to write tests for our application, automated tests. So basically code that runs our code and tests it for certain things. Certainly important once you're a bit of a more advanced Dart and Flutter developer, but not important for us right now, and therefore we can safely ignore this. Gitignore is a folder that helps you when you're using Git, which is a source code management tool. It allows you to create snapshots of your code, save them, and you can go back to them at a later point of time if you messed up something or if you wanna change something. It is not a tool you have to use, but often during development, Git can be really useful. And after this lecture, you find a short text lecture on Git. Using it is totally optional, but if you want to use it, if that sounds interesting to you, that lecture will help you get started with it, and then you can use it if you want to use it. The metadata file is not really a file we will work in. It will be managed automatically by Flutter. And in the end, the Flutter tool simply saves some information in here, which it needs to well, build our application correctly and so on. The same is true for the .packages file. It's not a file we'll do any work in. This is generated automatically by the Flutter SDK. And in the end, this also just manages some internal dependencies, some packages this project needs, and it is fully managed automatically. You should not delete it, but you also shouldn't work in it. This file here, this .iml file, which has your project name as a name, is also a file where we will not work in. It's also managed automatically by the Flutter SDK to, again, manage some internal dependencies and some settings for this project, you could say. And it's not a file which we will change. Now, the pubspec.log file is also not a file we'll work in, and it becomes clearer once we understand the pubspec.yaml file, which is a file in which we will work. This is a file that allows you to mostly manage the dependencies of your project. Now, what does this mean? This means that here you can configure which other third-party packages your project might be using. You can also configure some other things in here, like for example, fonts you want to use or images you want to use in your application. And we'll use all these features. We'll work with third-party packages and we'll use fonts and images. And therefore, I will show you how to work with this file and how to change it to include new fonts or new images. I will show you all of that step by step. Basically, what you have here is code written in YAML, which is a certain format for structuring text files, where you use indentation to express how code works together. And here, for example, we're right now specifying with which Dart version this works, which version our application should have, also which other third-party packages we might be using, like here the Cupertino icons, which allows us to use certain iOS styled icons in the application, and we'll add other third-party packages throughout this course here. So this is basically a config file that allows us to configure how our application works or which external dependencies it has. For the moment, we don't need to change anything here. The pubspec.log file, in the end, is a file that is generated automatically based on your .yaml file here, and this simply holds more details than about all the dependencies you have, and it is required by Flutter, but it's not a file you will work in. In the end, as I said, it will be generated automatically. We will only work in the YAML file. Well, and the README file is an automatically generated README file, which, well, we can ignore. It holds some information about our project, and you could change this here if you were sharing your project with other developers and you want to give them some information. So that was a thorough walkthrough through all the folders and files. The core takeaway is that we will work in the lib folder and sometimes with that pubspec.yaml file, and we can basically ignore all other files and folders. With that, it's time to really dive into the code, and for that, let's look into the only Dart file we have at the moment in our lib folder. It's the main.dart file, and since this is the only Dart file we have right now, and since I mentioned that this is the folder in which we will write our entire application in the end, this has to be the file that is responsible for giving us the output we're seeing here, so for giving us this application. And indeed, that is the case. This single file holds all the code that renders this application onto the screen. And how does it do that? Because overall, this is a pretty lean file. It doesn't have that much code. All these green lines here with the double slashes at the beginning are just comments. So this is not even code that does something. It's just there for you to explain what happens thereafter. So in the end, this is a really lean file. What is this file doing here? We will rewrite this file to create an application from scratch. But before we do that, I want to briefly walk you through it so that you get an understanding, a basic understanding of how such a Flutter application works and what Flutter does for you. Flutter, as you already learned or as I already mentioned, is both a tool set and a framework, a programming framework for the Dart language. And in the end, a Flutter app is an application where you, the developer, build a UI by adding widgets. Widgets are components, the building blocks of your user interface. Like this button here in the bottom right corner, that would be a widget. The text here, that would be a widget. The app bar here at the top and the title in there, that would be widgets. And that's what you can see in the code here. Even if we don't understand all of that code, if we scroll down a little bit here to this build method in that my homepage state thing, which is totally unclear for now. But if we scroll down there, we can identify things like app bar or things like text and another text or things like a floating action button. And even if you don't really understand Dart and Flutter, it probably makes sense that this floating action button is kind of related to that floating button we have here in the bottom right corner. And the two text pieces we have here, text and text, where we see you have pushed the button this many times, that seems to be responsible for giving us this text here in the middle. And indeed, that is how this works. These are widgets which we didn't create ourselves, but which are built into Flutter, which ship with the Flutter framework, which we can use to put some text onto the screen or to add a button to the screen. And of course, we got way more widgets than these two different kinds of widgets. We got widgets for different kinds of buttons, for drop downs, for images, for lists which we can scroll, for so many things. And that is how Flutter works. You work with these built-in widgets and you build your user interface based on them. And you can configure all these widgets to change their colors, or for example here, to change the text size. And you can also build your own widgets, which take these built-in widgets and group them together to build a brand new custom widget, which you can then put somewhere. For example, you could be combining this smaller and this bigger text, and then have your My Custom Output widget, which always prints or draws this smaller and bigger text on the screen if you would need this combination in other places of your app too. And we'll dive into all of that throughout the course, and I will explain Dart and how Flutter works and how you create such widgets whilst we are diving into that, no worries. Here in this starting code, we can already see that here we seem to be doing something with a widget, so maybe this is code that does create a custom widget, and indeed we're doing that here. But again, I think it makes more sense and it's easier to understand this if we do that step by step. And for that, let's actually select the entire code in the main.dart file and delete it. Now, why am I doing that? Because I want to create a complete app with you from scratch. I could just give you the instructions on, okay, now add this, now let's do that. And you would have a working application, but you would learn nothing about how it works. And it's super important to understand how it works and why you write which code, not only to learn Dart, but also to learn how Flutter works. And that is what you need to build your own Flutter apps. Because otherwise you can only build exactly the same app I show you, but I want you to be able to build any app. And for that, you need to learn it from scratch. So let's remove all that code in main Dart. Let's save the file. It now automatically rebuilds the app and syncs it back, and therefore this now crashes because we're not starting anything here, and we get an error here at the bottom. And that is all right. We will now write our own code here. Now, with our main.dart file now being totally empty, I will first of all walk through some programming and Dart fundamentals before we continue rebuilding our app from scratch. Now, if you already are a more experienced developer, if you worked with JavaScript or Java or C#, then you will already know a lot of the things I'm going to explain. Still, there will be some Dart specifics, and therefore I would recommend that you don't skip this lecture, but instead maybe just ramp up that playback speed if it's boring to you. If you're brand new to programming or you're never programmed before, well, then you should definitely follow along. Now, for these basics, we'll not stay here in our project at the moment because we couldn't really execute that code here since we have no working app at the moment. But instead, you can Google for Dartpad, and that is a web-based playground that allows you to write some Dart code and run it in the browser. And that's exactly what I have here. This is a little demo starting project, which we start with, but we'll write our own code here in a second. So this is Dart code, not a Flutter app, just normal Dart code. You could also use Dart for web development. This is just some dummy Dart code where we see the output here on the right in the console, and it's perfect for learning the basics about Dart. Now, what do we have here? The overall thing we have here, this main thing, that is a so-called function. Functions are a crucial concept in pretty much any programming language you're going to learn. Functions are code snippets which you can execute multiple times and at any time you want. This function here is named main because the thing in front of the parentheses here is the so-called function name. The parentheses themselves are always required for every function you define, and they allow you to receive so-called arguments that would be input to your function. And this function simply doesn't take any arguments. Nonetheless, it needs these parentheses to turn it into a function. Then we have curly braces, the green ones here right now. Curly braces surround the so-called function body. That is the code which executes when this function gets called. And I will show you how to call a function in a second. Void here, that is a so-called type. Dart is a typed language, which simply means that everything in Dart has a type. Here, that is the type of data which this function returns. This function returns nothing, and therefore the return type is void. It's empty, so to say. Here we see a number type in this strange for thing, to which I'll come back later. This would be the type of I. I holds a number, a so-called integer. But more on that in a second. Let's not learn too much at the same time. So this is a function called main. It has no arguments and it returns nothing and therefore has a return type of void. This is the function body. Main is a special function name. Generally, you can give your functions any name you want, but main is a special name because main is the entry point of a Dart application. Dart automatically calls the main function for you when the app starts. Therefore, in a Flutter app, when you add main in the main Dart file, which is also a special file for which Flutter will look for, when you add a function called main here, by adding parentheses and by adding void in front of it, this is the first function which Dart and Flutter will execute automatically when your app launches. So into this function, you need to put the code that basically kicks off that UI rendering work that brings something onto the screen. More on that in a second. So that's a function, and main is a special kind of function. Now, because it's a special kind of function, you probably also can create other functions, right? And you can. Let me first of all remove that code inside of the function. And let's add a new function above the main function. And I will name this add or add numbers. That name is now totally up to you, but you should follow a naming convention, which is called camel case, where you have only one word, so no blank in between. That would actually be a syntax error. But you have one word, and if your word actually consists of multiple words, like this one, add and numbers, then all words should always start with a capital character, even right inside of the word. But the first word always starts with a lowercase character. So you have add numbers. If this would just be called add, then you would also start with a lowercase character. But any other word in there has an uppercase character. That's just a naming convention which we use in Dart and also in many other programming languages, which you should memorize and use so that when other developers see your code, they have an easier time understanding it. Now, as I mentioned, a function can take arguments, so input. Now, the main function didn't take any arguments, but let's say add numbers is a function which should hold some code to add two numbers. And therefore, this will now take two numbers as an input. So between the parentheses here, we can add num1 and num2. And just as the function name, these names are also up to you. You can name that whatever you want. And as you see here, you simply add commas as a separator between your different arguments in the list of arguments here. Now you also need a function body, and you add that by using curly braces. That simply tells Dart that in between the curly braces, you have the code that should execute when this function gets called. So when you instruct it to execute the code inside of add numbers. Now you do instruct Dart to execute this function by using its name, now in the main function, which is the code that first runs when the app starts. So in here, in main, you simply call add numbers by its name. And now here you also need to add parentheses. You always need to do this, even if the function takes no arguments. This function, however, does take arguments. So now between these parentheses, you add the concrete values, which will be passed to add numbers. So that num1 and num2 do have actual data with which they can do their work. So here we could add 1 and 2. Now, of course, this function doesn't do anything at the moment, though. I call it with 1 and 2 here, but we have no logic in there to really add these numbers. So what we can do in here is we can call num1 plus num2, and now we would add that. Now, we also need to add a semicolon. That's another thing in Dart. For every expression you have in your code, for every code line, you have to add a semicolon in the end. Exceptions from the rule are the definition of functions, where you don't add a semicolon after this curly brace here, but you do add it here for all the code inside of your functions, so to say. And in general, for all these block statements, as they are called, so these statements where you have code between curly braces, you don't add a semicolon after the curly braces, you only add semicolons after the expressions between curly braces. So here we have num1 plus num2. I added this semicolon here. But the problem we now have is we add two numbers here, and that would generally work, but we're not doing anything with the result of this operation. Now you could think that it should automatically be output here on the right. Well, let's see. Let's click run. What happens is that we have an empty output here on the right. So that's not really helpful. Now, in programming, you always have to be very clear about what should happen, because the programming language, Dart in this case, does not make any assumptions. Why would it print it here? You don't tell it to do that, and therefore it doesn't do it. Now, you can print the result by using the print function. Print is not a function we defined, it's a function that was that's built into Dart. And you can wrap num1 plus num2 with print, and if you now hit run, you will see 3 here on the right. So now this works. Now we're outputting the result of num1 plus num2. So this is our first little piece of Dart code, and yet we can improve that. For example, we don't use types here, but Dart is a strongly and a strictly typed programming language. That means that you have to be clear about which type of data your arguments are, or this function returns. That is something which helps the Dart compiler to yell at you when you write code that violates that. If you don't assign your own types, which we'll do in a second, then Dart will assume that this is of the dynamic type, a type built into Dart, which, as the name suggests, doesn't tell too much about the type. It basically accepts any value, and therefore it won't really help you that much with checking that you're writing proper code. So if possible, you should avoid that dynamic type and assign explicit types when working with Dart. Now, there are a couple of built-in types in Dart. Everything in general is a so-called object, which is a data structure that has, some complex logic inside of it, possibly at least. And we'll create such objects later too. But there are certain special types of objects, you could say. There is text, for example, and you create text by using quotation marks. So here, if I type hello and I print this, please note the quotes. You can use single or double quotes, that doesn't matter, but you shouldn't mix them. So if you open it with a double quote, you also have to close it with a double quote. I will use single quotes in this course though. And this creates a so-called string data type. So this is a value which is of type string. Text simply is a string. If we now hit run here, we'll see hello being printed because, well, I'm printing this here, and therefore we see the output here. So text, strings, are one data type. Besides the text, for our numbers, we have so-called integers and we have floats or doubles. Integers are numbers without any decimal places, like 29 or 43 or -10. Floats or doubles are numbers with decimal places, like 29.99, -10.56, something like that. So here, these two numbers would actually be integers. Now, in this function here, we should be clear about the fact that this only works with integers. And we do that by adding int in front of each argument. This tells Dart that num1 and num2 both have to be integers. So if I now run this, it will still work. But if I would pass 2.5 or 2.6 here, then we actually automatically get an error here in the bottom right corner that our argument of type double can't be assigned to a parameter. Parameter is basically a different word for argument of type int. And that is why Dart does use these types, because it allows us to write cleaner and better code. If we know that this function should only work with integers, then we should define it as such. And if we then later, somewhere else in our code, accidentally call that with a double, we get an error. And we get that error before we ship our code into the Flutter app, so into the app stores, for example. And that is, of course, good. We want to catch and fix errors whilst we are developing. So here, we would get an error. Now we have two possible fixes. Either we fix our code such that we only call that with an integer value, or if we see no, this should actually also work with doubles. Well, in such a case, we could of course change that and accept doubles as inputs. And now if we run this code would work again, and it would output a double here with a decimal place, because now we allow doubles here. Now, of course, you could think, why don't we always use a double then? It's more flexible than an int. Well, sometimes you have situations where you really only want to have numbers without decimal places. Let's say you have some counter, which only increments by 1 at a time. Well, then you should be clear about that being an int so that you can't accidentally run the code with the invalid value with a decimal value. Now, side note, we could have also used num here, which is the overarching number type, and that would allow both ints and doubles. But as you see, if we use double here, this also allows us to call this with a 1, because this implicitly is converted to a double. So we can really use double here if you want to allow both double and int. So this works, and with that we learned about text, so-called strings, and about numbers where we have integers and doubles. And that all can be used as types, which we, for example, pass to a function. Now, this function, however, might also return something, or it might not. And you should therefore also always add a type information about what type of data this function returns. Now, this function prints the result, and therefore it does not return anything to the place where we call it. Hence, the correct type here would be void. Void is a special type in Dart, which basically means nothing. This function returns nothing. Now, why is that important? Because if we now, for example, wanted to print the result of add numbers here, like this, then we get an error that the expression here has a type of void and therefore can't be printed. We can't print the result of us calling add numbers because add numbers doesn't return anything. Sure, it prints something, but that is done from inside the function. Here, we would want to print what this function gives back, and this function doesn't give us anything back. However, we could actually make sure that it does. Instead of printing in here, let me comment this out, which you can do by adding 2 forward slashes. Now this code won't be considered. And this is a common pattern, by the way, that you comment out code which you don't want to run, but maybe you want to use it later, so you don't want to delete it, but you simply comment it out so that it's still there but not executed. And now we could return something here by using a special keyword in Dart, which is return. Now this is a keyword which tells Dart that this will now return something to the place where you called the function. So here I return num1 plus num2. And now what this does is, now here, this is valid code, because now here we print the result of add numbers, and the result is what add numbers returns, and here we return 2 numbers. If I now run this, we get an error though, that we can't return a value because this expression has a return type of void. And again, this is a good thing. We defined that add numbers doesn't return anything, that it returns nothing, and yet we do return something here. Now the solution is to change the return type here. And here we can change this to double, because since we add 2 doubles, we will always return a double. So now I'm returning a double here. And now if I call this function and I run this, now we don't get an error and we see 3.6 here instead. And this is how you should write Dart code. You should use these types. You have the core types of string and numbers, where we have integers and doubles. We have a couple of other types too, which we'll learn about throughout this course. And this is a core concept of Dart, just as functions are a core concept of Dart. Because now we can call add numbers here as often as we want. So I can also call add numbers here with 2 ones, for example. And this is a really useful pattern and feature which you have in basically any programming language, because it allows you to write code once, this logic for adding code, and you can call it with different inputs as often as you want. And therefore functions are a really important concept in programming and also in Dart. We had a first look at some programming basics, functions and types, or some of the important types for the moment. But there is more in programming, and there are 2 other features which we need to understand before we can go back to our main Dart file. The first feature is the feature or the idea of variables. Thus far, what I always did in here is I always immediately printed the result of add numbers. Of course, this is just some simple dummy code, and therefore this makes sense here. We basically just want to see what this yields us here. In reality, however, you often write programs where you also need to store the result of some calculation or some user input. You want to store it somewhere so that you can use it later. Now with store, I don't mean in a database, but in memory, because you need it later, a couple of code lines later in the same code. So we don't want to write it into a file or store it in a database. We just want to store it in memory so that when this code executes, we can take it and use it a couple of lines further down, for example. And we can store data with the help of so-called variables. Now let's say that first result here shouldn't be printed immediately, but instead I do want to store it in a variable. You create a variable by giving it any name you want, like first result. And the naming convention here is just the same as for functions. You use camel case, lowercase starting character, then only one word, and every word inside the word starts with a capital character. Now that's first result, and you assign a value to that so-called variable now with an equal sign. Now it's called variable because the data in there is variable. You can change it. Here I'm storing the result of add numbers in first result. I could reuse that and now also store that result in first result. So after the first line, the result of add numbers for 1 and 2.6 would be stored in here. After the second line here, the result of add number with 1 and 1 would be stored here. And the first result, so this result of this line here, would be dropped. We would store that result in the first result variable now. However, we have a syntax error here, and that means that Dart doesn't understand this. This is almost the right syntax, but to tell Dart that this is a variable, you need to add the var keyword here when you create that variable for the first time. So not in this line, where I then use it again, the same variable with the same name, but when you introduce it, then you need to add the var keyword to tell Dart that this is a variable. And now we can, for example, use that result, that first result, whoops, the name is first result, we can use that here in a separate line. Sometimes you even just use a variable to make your code easier to read so that you can split it across multiple lines. Sometimes you have some other code in between that you need to execute first, and then you want to use first result later. Maybe you even want to combine it with some other calculation that you add +1 to it. That would be possible too. First result simply holds the value returned by add numbers. And that number in our case is a double. So you can do anything with it, which you could do with any other double. So now if I run this, we print 3 here because first result has the result of add numbers with 1 and 1 stored, which is 2. And then we add 1 to it. So we have 2 + 1, and we print that result, and therefore see 3 here. Variables are a core feature in Dart, and we'll see it a lot throughout this course. Now, besides that syntax, where I use var for creating it, you can also create it by adding the type of data which this variable will hold eventually. So in this case, we could also write double first result. However, Dart also has a feature called type inference. This means it's able to infer the type of data you'll store here by the value you have on the right side. Here, since I call add numbers, which returns a double, and which always returns a double, Dart is able to infer that first result will hold a double. And therefore, you don't have to tell Dart that this is the case. And actually, it's considered a better practice to then just use var. It would be a different thing if you created the variable like this, without assigning an initial value. That is possible too. The variable now exists, but it is uninitialized. And sometimes this is also something you need to do because you want to create a variable and at a later point of time you want to assign different values to it. In such a case, it is a good practice to tell Dart which kind of data will eventually end up in this variable. So then you should use the type here instead of var. In this case, that's a double. When I run this, we see the same output as before, but now we created this a bit different and we are using double instead of var here. Now that's one of the important features which I wanted to mention. Another important feature is that Dart is a so-called object-oriented programming language. I did mention that everything in Dart is an object. So this number, this one here, is an object. Now, you would say it's a number, and that's true, but a number is just an object. Now, what is an object? Everything in Dart is basically a data structure with a lot of different information in it. Now, here the information is, of course, that it's 1, but there is some other metadata which Dart uses internally, you could say. Now, why do we actually start expressing our data structure as objects? Well, that is simply related to the real world. If we think about the real world, we work with objects there too, right? You have a car and you can drive that car, or your car has a certain amount of seats or a certain amount of horsepower. So we describe our real world with objects. And the idea simply is to bring that way of thinking into development, into programming, so that it's closer to the real world. So we work with objects in our